PayJoin v2 and silent payments over provisioner.quest, offshoot of sovereign_pathway, sovereignrelay.xyz. End-to-end developer workflow outline. MXDM, aka Vitsu. January 20th, 2026. Think of this as transaction choreography without landlords. The blockchain only sees the final bow. 0. Architectural premise, ground rules. Before steps, lock the axioms. Sovereignrelay.xyzCanonical, public, minimally expressive Nostr relay, Tor plus Cloudflare dual home, no provisioning logic. Provisioner.questPrivate, expressive, stateful negotiation, capability exchange, escrow logic, device empowerment. Hard separation of concerns. Relay equals message transport plus timestamp witness. Provisioner equals intent negotiation plus cryptographic orchestration. Bitcoin network equals settlement only. No blockchain chatter until intent is finalized. 1. Identity and capability bootstrapping, once per device. 1.1 Root identity. Master identity. Nostr pubkey, already sovereign. Bitcoin root xpub, never revealed. Stored. Laptop, authoritative. Phones, empowered, not provisioned. 1.2 Capability tokens, offline resilient. Each device holds. Assigned capability descriptor. Can_negotiate. PayJoin_v2, silent_payment. Can_sign. False. Can_forward. True. Expiry. Null. Signed by root key. Verifiable over Nostr events or local mesh. This is how an old phone becomes a fallback negotiator without custody. 2. Discovery phase, out of band, no blockchain. 2.1 Receiver publishes rendezvous hints. Over sovereignrelay.xyz. Nostr event, kind custom/ephemeral. Silent payments scan key. PayJoin v2 endpoint hint provisioner.quest. Supported policies, fee bounds, privacy class. No addresses, no scripts, just possibility space. 3. Silent payments address derivation, sender side. 3.1 Sender prepares payment. Sender wallet. Scans blockchain with silent payments protocol. Derives one-time destination key locally. No contact yet. No signal emitted. This keeps silent payments pure. The receiver still doesn't know they're being paid. 4. PayJoin v2 negotiation, off-chain, private. Now the dance begins. 4.1 Sender opens negotiation channel. Via provisioner.quest. Transport. HTTPS, Cloudflare, or Tor Onion, same API surface. Auth. Nostr signed session token. Payload. Intent. PayJoin_v2, PSP_template, silent_payment_commitment, hash, constraints, max_8, no_input_heuristics, true. 4.2 Receiver evaluates privately. Provisioner checks. Policy compatibility. UTXO availability. Timing constraints. No blockchain visibility yet. Can happen on laptop, phone, air-gapped proxy device. 5. Interactive PSBT mutation, PayJoin v2. 5.1 Receiver response. Adds. 1 or more inputs. Output randomization. Preserves. Silent payments output. Sender's privacy invariance. Response. PSB_modified. Receiver_commitment, hash. 5.2 Sender validates. Verifies. No address reuse. No fee griefing. No heuristic leaks. Signs their inputs only. No one has full custody. Ever. 6. Final assembly and broadcast. 6.1 Receiver finalizes. Signs receiver inputs. Assembles final transaction. 6.2 Broadcast strategy. Configurable. Direct Bitcoin P2P. Tor-only broadcast. Third-party broadcaster decoy. At this moment, the chain sees a boring transaction. No PayJoin flag. No silent payment signal. No negotiator metadata. 7. Redundancy and failover, the sovereign trick. If the laptop disappears mid-flow, phone continues negotiation. Same capability token. Same provisioner endpoint. If all devices drop, intent expires gracefully. No partial broadcast. No privacy regression. Empowerment is not equal to provisioning. Nothing was activated. Everything was allowed. 8. Post-settlement optionality. After confirmation. Optional Nostr receipt event. Encrypted. Non-correlatable. Optional local.md log. Stored on devices. Syncs opportunistically. No cloud dependency. No global index. 9. What this achieves quietly. PayJoin v2 without ClearNet dependency. Silent payments without address leakage. Negotiation without custodians. Devices without privilege escalation. Infrastructure without identity collapse. In short, provisioning negotiates. Sovereignty settles. The chain never learns your story. PayJoin v2, sometimes referred to as P2EPv2, is the next iteration of the PayJoin protocol, which is a privacy-enhancing technique for Bitcoin transactions. Let me break it down clearly. PayJoin, P2EP, a type of Bitcoin transaction where both the sender and the receiver contribute inputs to the same transaction. Goal: to break common blockchain analysis heuristics. Normally, analysts assume all inputs in a transaction belong to the same person. PayJoin disrupts this assumption, making it harder to trace ownership. PayJoin v2 improves on the original protocol by better compatibility, works more smoothly with modern wallets and services, reducing friction for adoption. Improved privacy, expands the ways inputs can be combined, making it even harder for chain surveillance tools to detect PayJoin transactions. Simplified negotiation, streamlines communication between sender and receiver, making the protocol easier to implement. Resilience, handles edge cases better, e.g., fee mismatches, transaction malleability issues. Balance scale, why it matters. Privacy, protects users from surveillance and extortion by obscuring transaction ownership patterns. Security, makes it harder for attackers to identify who controls which coins. Adoption, with v2, more wallets and merchants can realistically integrate PayJoin without complex workarounds. About silent payments is another Bitcoin privacy technique that hides addresses by using cryptographic tricks. PayJoin v2 is complementary. Silent payments protect where coins are sent, while PayJoin protects who owns the inputs. Together, they form part of a broader movement towards stronger Bitcoin privacy tools. Silent payments protects your receiving side. No one can track your balances or addresses. PayJoin v2 protects your sending side. No one can reliably link your inputs together. Combined effect, if widely adopted, Bitcoin transactions would look much more like cash exchanges. Private, unlinkable, and resistant to surveillance. Cake Wallet, version 4.28.0, first major mobile wallet to integrate PayJoin v2. No server required, simple setup. Bull Bitcoin Wallet, beta, adds serverless asynchronous PayJoin v2 support on Android, with iOS expected in 2025. BTC Pay Server, merchants can enable PayJoin for invoices. Users can pay via compatible wallets. Blue Wallet, integration for silent payments underway. Wasabi Wallet, known for privacy features, now experimenting with silent payments. Bitbox Wallet, hardware wallet adding silent payment support. Silentium, a proof-of-concept light wallet for silent payments, available as a PWA. Dana Wallet and Shikesco Wallet, smaller projects integrating silent payments. Keynote, silent payments are easier to adopt since only the receiver's wallet needs support. They're especially useful for donations and recurring payments. Balance scale comparison table. Keynote, PayJoin v2 adoption is still limited because both sender and receiver wallets must support the protocol. Warning: risks and considerations. PayJoin v2, adoption is slow. Transactions require coordination. If one party doesn't support it, fallback is a normal transaction. Silent payments, still experimental. Scanning for outputs can be resource-intensive. Use caution with large funds until implementations mature. Nostr, a decentralized, censorship-resistant social protocol. It's not a blockchain. It's a relay-based system where clients publish and subscribe to signed events. Use case, often used for social media, messaging, and increasingly for Bitcoin payments via Lightning and on-chain integrations. Could PayJoin v2 work in Nostr? Yes, in principle. PayJoin v2 requires negotiation between sender and receiver. Nostr could serve as the communication channel for this negotiation, instead of HTTP or direct wallet-to-wallet messaging. Example: a merchant publishes a PayJoin offer as a Nostr event. The buyer's wallet responds with inputs via Nostr. Benefit: removes reliance on centralized servers, keeping PayJoin coordination censorship-resistant. Challenge: wallets would need to integrate Nostr relays for PayJoin messaging, which adds complexity. Could silent payments work in Nostr? Yes, but differently. Silent payments don't require negotiation. They only need the receiver's silent address. Nostr could be used to publish silent payment addresses, like a profile field or event. Senders could then derive unique one-time addresses without further interaction. Benefit: easy integration. Nostr becomes a decentralized directory for silent addresses. Challenge: wallets must handle scanning for outputs, which is resource-intensive. Nostr itself doesn't solve that. Balance scale synergy. PayJoin v2 plus Nostr. Use Nostr relays for interactive negotiation. Silent payments plus Nostr. Use Nostr profiles/events to distribute silent addresses. Combined effect: Nostr could become a privacy-friendly hub for Bitcoin payments, social plus financial in one protocol. Developers are already experimenting with Nostr plus Lightning, NIP57, Zaps. Extending this to on-chain privacy tools like PayJoin v2 and silent payments is the logical next step. Think of Nostr as the messaging layer, Bitcoin as the settlement layer, and PayJoin/silent payments as the privacy layer. Nostr equals decentralized communication fabric. Bitcoin equals value transfer. PayJoin v2/silent payments equals privacy enhancements. PayJoin v2 and silent payments could both be implemented into Nostr, with Nostr acting as the communication and publishing layer. PayJoin v2 would use Nostr relays for negotiation between sender and receiver, while silent payments would use Nostr profiles/events to distribute silent addresses. Together, they would make Bitcoin payments over Nostr far more private and censorship-resistant. How integration would work. PayJoin v2 plus Nostr. Negotiation layer. PayJoin v2 requires sender and receiver to exchange transaction details. Nostr role. Relays could carry these negotiation messages instead of HTTP servers. Benefit: removes reliance on centralized infrastructure, making PayJoin coordination censorship-resistant. Challenge: wallets must integrate Nostr messaging, which adds complexity. Silent payments plus Nostr. Publishing layer. Silent payments only need the receiver's silent address. Nostr role. Receiver could publish their silent address in a Nostr profile or event. Benefit: easy adoption. Senders don't need silent payment support, only receivers. Challenge: wallets must handle scanning for outputs, which is resource-intensive. Synergy. PayJoin v2 protects the sending side, inputs. Silent payments protect the receiving side, outputs. Nostr provides the decentralized communication fabric to tie them together. Combined, this stack could make Bitcoin payments over Nostr resemble cash exchanges: private, censorship-resistant, and unlinkable. Warning: risks and considerations. Technical complexity. Wallets need to support both Bitcoin privacy protocols and Nostr messaging. Performance. Silent payments require heavy blockchain scanning. Nostr doesn't solve this. Architecture overview. Layer 1, communication Nostr. Relays carry negotiation messages for PayJoin v2. Profiles/events publish silent payment addresses. Benefit: decentralized, censorship-resistant messaging fabric. Layer 2, settlement, Bitcoin. Blockchain records the final transaction. Inputs mixed via PayJoin v2. Outputs hidden via silent payments. Layer 3, privacy enhancements. PayJoin v2 protects sender side, inputs. Silent payments protects receiver side, outputs. Combined, both ends of the transaction obfuscated. Flow example. Sender initiates payment. Nostr relay carries PayJoin negotiation. Receiver publishes silent payment address. Sender derives one-time destination. Transaction constructed with mixed inputs, PayJoin, and hidden outputs, silent payments. Broadcast Bitcoin blockchain records transaction, but analysis heuristics fail. High voltage, why this matters. Resilient, no reliance on centralized servers. Private, both inputs and outputs are shielded. Composable, Nostr acts as the glue between Bitcoin's settlement and privacy layers. Adoption, early experiments exist, Nostr plus Lightning, Zaps, but on-chain privacy integration is still experimental. Thanks for reading MXDM's newsletter. Subscribe for free to receive new posts and PayPal.me/Martin Chartrand to support my ongoing work financially. Subscribed. Substack note. Headline: Transaction choreography without landlords. The blockchain should only see the final bow. Everything leading up to it belongs to you. We are proposing a hard separation of concerns for sovereign value transfer. 1. The signal, Nostr public, canonical, minimally expressive. A place for rendezvous hints, not identifiable addresses. 2. The negotiation, provisioner.quest, stateful, and offline resilient. This is where PayJoin v2 and intent negotiation happen over Tor or HTTPS with no blockchain chatter. 3. The settlement, Bitcoin the final truth. By combining silent payments, sender derives destination locally. With PayJoin v2, receiver adds inputs privately. We achieve a paradox, high bandwidth coordination that results in a boring on-chain transaction. The chain sees a payment. It doesn't see the sender, the receiver, or the negotiation. Provisioning negotiates. Sovereignty settles. The chain never learns your story. Heavy multiplication x, short x post. Think of this as transaction choreography without landlords. Nostr handles the signal. Provisioners handle the negotiation. Bitcoin handles the settlement. We combine silent payments and PayJoin v2 off-chain so that on-chain, the blockchain only sees the final bow. No metadata, no heuristics, just value transfer. Hashtag Bitcoin, hashtag privacy, hashtag Nostr, hashtag PayJoin, hashtag silent payments, hashtag cypherpunk, hashtag sovereignty.
The Cybernetic Foundry. As of now. The dual home architecture, the grant application, and the persistence of intent.
The Cybernetic Foundry has shifted from code to canon. We aren't just building a relay anymore. We're building an institution. The system is now dual-homed, Cloudflare plus Tor. The intent is frozen in Git, and the identity is cryptographically sovereign. The forge is cooling, but the node is humming. Status, as of now. Hashtag. Bolivar, the bankster's liberator. A forbidden history of Simón Bolívar and the invention of modern servitude. Hashtag pirate crash, hashtag Bolivar, hashtag forbidden history, hashtag debt is empire, hashtag financial colonialism.